Okay, welcome to lesson 109, solve systems of equations by substitution. So today we're going to do a little bit of algebra. So the last video we solved equations by graphing, and now we're going to do it by substitution. Okay, so here's our objective, here's our vocabulary. So this is the whole point for doing systems of equations. You have two lines or more, and you're looking for the point of intersection because, as you can see, one line is going up, and at this point, it intersects with the other line. So before the lines, let's say this was your cost of doing business, and this was your overhead or something. You're selling fruit. You got to buy fruit to sell it. So the red line represents how much money you start with. The blue line might represent how much fruit you have to buy. And after you sell so much, then this is the point where you start to make a profit. So if you sell X many pieces of fruit, this will be your profit. So you have three choices. They either intersect at one point, they never intersect, or they're the same line. So that's the big idea with systems of equations. Okay, so we're going to substitute y equals 2x. And so what does that mean? If y equals 2x, well, you put the 2x into y. So you get 2x equals x minus 4. And now this becomes a situation where you have a variable, one variable, or a variable on both sides of the equation. So now what you do is you solve your equation. You subtract x from both sides. 2x minus 1x gives you 1x equals negative 4. So when x is negative 4, that is your x coordinate of your point. Now what you have to do, and most people forget to do, is you have to put the negative 4 into both equations. And so now I'm substituting into the first one. Always substitute using parentheses so you keep your sign straight. So negative 4 minus 4, and we know that same signs add. Okay, so we get negative 8. Now we had to check it against the second equation. Y equals 2x. So y equals 2 times negative 4, and 2 times 4 is 8, so negative 4 must be negative 8. So this works. So this means that both of these lines intersect at negative 4, negative 8. So if you were graphing that, and this was negative 4 on x, and this was negative 8 on y, one line, 2x. One line would be something like that, and x minus 4, and one line would be something like that. Just to give you an idea of what it would look like on a graph. I mean, I don't have numbers ticked off or anything like that, but this is the point. This point is the point of intersection at negative 4, negative 8. These two lines intersect. Okay, so now let's look at 2. You get y equals negative x minus 4 and y minus 3x equals 8. So I'm going to take this, and why am I taking this? Because the y is by itself. Here the y is not by itself. You would have to add 3x to both sides in the second equation, and then you can set them equal to each other. But since this y in the first equation is by itself, I'm going to stick it in there. And so what do I have? Negative x minus 4 minus 3x equals negative 8. So I get negative 4x because there's one x right there. Minus 4 equals negative 8. I add 4 to both sides. I get negative 4x equals negative 4. If I divide both sides by negative 4, I get x equals 1. So when you solve an equation, your variable x or y must be positive. It must be 1. The coefficient must be 1. And it must be by itself. Nothing can be added or subtracted away from it. Okay, so now we got x equals 1. So now we have to stick 1 into both equations. So if I do negative of 1 minus 4, I get negative 1 minus 4, which equals 5. And if I get negative 3 times 1 equals negative 8, y minus 3 equals negative 8. Add 3 to both sides, and I get y equals negative 5. Okay, so our point of intersection is 1, negative 5. Okay, let's look at our next example. Okay, so here what you have is you have x plus 2y equals 14, and then 3x plus 5y equals 40. When you have a situation like this, you have 2y here. If you solve for y, you're going to wind up dividing by 2. And you don't want to deal with fractions, so let's not deal with fractions. The coefficient in front of this x is already 1, so I would solve for x. So what I would do is I would subtract 2y from both sides. I get x negative 2y plus 14. Now that I have the x by itself, I'm going to take this and substitute it in to x. And don't forget about this 3. Most students forget about the 3. So watch this. And this is another reason why you put things in parentheses. 3, negative 2y plus 14 plus 5y equals 40. Now I have a situation where I only have one variable. I'm only dealing with y's. So let's do the math on this. So we got negative 6y plus 42, 3 14s is 42, plus 5y equals 40. So if I subtract 42 from both sides, I get negative 6y plus 5y equals negative 2. Negative 6y plus 5y. Same signs add, different signs subtract. I get negative 1y equals negative 2. I cannot have a negative 1 as a coefficient. So I have to divide both sides by negative 1. And now I have y, positive 1y equals positive 2. So now, in this one, we solve for y first. Now we have to go back and put this y into both equations. And I know it seems like a lot, but you have to do it this way to check and make sure that it works in both equations. Subtract 4, x equals 10. Okay, so now I had to check it into the second equation. 3x plus 5 times 2 equals 40. 3x plus 10 equals 40. Subtract 10. 3x equals 30. Divide both sides by 3. And then x will equal 10. 10 works. My point of intersection is 2, 10. So that's what we're looking for here, is the point of intersection. Okay, so those were our practice problems. You see me? Now you try. Those were our examples. Next up are 4 practice problems. Try those, and I will meet you back at the end of the video for a recap. Okay, so I gave you a little word problem here to say a school selling ornaments to raise money. It spends $2 to make each ornament and a total of $36 for other materials. Each ornament will sell for $4. How many ornaments will need to be sold to make a profit? All right, so this one isn't exactly clear because I didn't give you straight variables. I need you to think. So this is where you had to start. Okay, so X is going to represent an ornament. And so 2X is the money spent. And then 4X is going to be money earned. And now it's hard to see how you have two separate variables or two equations out of this, but your first equation is going to be y equals 4x, because that will be your profits. Your second equation will be y equals 2x plus 36, which represents the money you spent. So you spent $36 on materials and $2 to make each ornament. And so now what we do is just like in the first one, we're going to stick 4x in for y. So 4x equals 2x plus 36. Subtract 2x from both sides and get 2x equals 36. Divide both sides by 2. X will equal 18. Okay, so now when x is 18, what is our y? Or the question asks is how many ornaments will need to be sold? If we solve for x, we think 18 ornaments is going to be sold. But what you're going to want to do is make sure you check. So 4 times 18, 4 times 8 is 2, 3, 72. 4 18s is 72. And then 2 times 18 plus 36. 36 plus 36 equals 72. So we get the same number. That's how much money we make. So how many ornaments do we need to sell? 18. So what was tricky about this one was letting x be the ornament. So the variable here was your ornament. And a 2 and a 4 were your coefficients because the numbers have to multiply to the variable. So that's that one, whatever. Okay, the length of a rectangle is 2 centimeters more than 3 times its width. If the perimeter of a rectangle is 28 centimeters, find its dimensions. Okay, so what we have here is a rectangle. And they give us the perimeter equals 28. And the perimeter equals 2 times the length plus 2 times the width. So that's a standard equation to find the perimeter of a rectangle. So it's 2 centimeters more than 3 times its width. So if the width is x, the length must be 3x plus 2. And now let's put that in. So W is W. All right, we're going to put these into here and put these into there. So the length. The perimeter equals 2 times 3x plus 2 plus 2 times its width, which is just W, or x. I should have called it x. I'm sorry. There should be x. So x gets substituted in for W, and this whole thing gets substituted in for L. And now what we do is, since 28 is here, we just put it in for 28. And so 6x plus 4 plus 2x, and you get 8x plus 4 equals 28. subtract 4, subtract 4. 24 equals 8x. Divide by 8. X equals 3. So if x equals 3, then 3 times 3 plus 2 is 11. And so if this side is 11, this side must be 11. If this side is 3, this side must be 3. So 11 plus 11 is 22, plus 6 is 28. So it works. So that's how you check. You can always check all of the work that you do by substituting it back in. So that is our lesson on solving systems of equations by substitution. So our next one we're going to look at is probably solving by substitution a little bit more difficultly.